Hi everyone, this is your next set of notes. We're graphing cube roots now instead, so you see the little threes right here. I'm actually just going to be we're just going to go over some practice examples. This is your homework that you will be doing. I would like you to do all of these because I am going to do number 7 and 8 actually for you. So you're going to basically just do 1 through 6. If you scroll down, you guys will be doing this on a separate sheet of paper. Please title it Graphing Radicals and in parentheses put cube roots so we know we're on that one, making sure we know what you're turning into me today. So for sketching the graph of each of the following and find/solve for the indicated information again. So we are going to be graphing our 1 minus the cubed root of x plus 2. And I want to show you guys another way of actually writing this because it looks a little weird that this is out in front. So this is actually just another way of making this guy, I know to make you guys confused, if we just have our g of x equal, this is actually the negative cubed root of x plus 2. And then that plus 1 is actually over here. It's just the thing outside. Sometimes they put it in front, of course, to confuse you. Right when you're getting something, we like to change it. So you have the negative cubed root of x plus 2, and that plus 1 is actually our shift up and down again. So remember, if we try and predict where our point is going to be, it should hopefully be at negative 2 and then plus 1. So we go 1, 2, up 1. So the same rule still actually applies for our cubed roots, that shift inside here is going to still be, actually this will be our middle point, our turning point on this one. So let's we're going to do the same thing, you guys. We're going to set up our table. We're going to set our radicand, the x plus 2. We're going to set it equal to what kind of perfect things do you think? We're actually going to set them to perfect cubes this time because we have our index of 3. So when I'm going to do this over here. So you guys can write this on your own piece of paper. So we have x plus 2. What are our perfect cubes? So now we have our perfect cube of 0. When I solve for x, I'm going to subtract 2 from both sides. And when I subtract 2 from both sides, I get x equals a negative 2. So remember, this is going to be my first x value. However, we can also do negative values. Remember, taking a cubed root, a lot of you guys got stuck on this. You didn't like these. Taking the cubed root of a negative 8 is actually negative 2. So remember, we could take negative cubed roots because a number multiplied by itself 3 times actually does get you a negative number. It's okay. So we will be using negative and positive cubed roots. So this was actually my middle turning point, one of my values. So I'm not going to actually put this first. Let's go through and just calculate all these first. So now let's do x plus 2. My other square, my perfect cubed, let's do negative 8. So if I do negative 8, I subtract 2 from both sides, and I get x equals negative 10. If you start off with the highest negative that you're going to be working with, that's most likely going to be your first x. So I just started off in the wrong order. And then now let's keep going because we want to try and get as many points as we can. So x plus 2. On this graph, I'm going to suggest that you need 5 points at least to actually graph these. So we already have our perfect cube of negative 8. We did 0, but I'm going to do negative 1 this time. Subtract 2. You should get x equals a negative 3. That's going to be my next value because that was my next negative perfect cube. Then my next one, so we did negative 8, negative 1, 0, and now I'm going to go upwards. So now I'm going to do a positive 1, subtract 2, and I get x equals a negative 1. Okay, so that negative 2 I do get to put right here now. Let me just try and be consistent on my colors. So negative 2, and then that negative 1 is going to be in the red. And then my last one is going to be x plus 2 equals, we already did negative 8, negative 1, 0, 1, and we're going to do a positive 8. So I'm going to subtract 2 from both sides, and I get x equals 6. So that will be my last value in my table there. So you should have negative 10, negative 3, negative 2, negative 1, and 6. Now, when you plug these values in, let me get rid of this. So now when I plug these values in for my x, I'm going to get my y's. So again, you're going to have 5 points on these graphs. That little turning point, that when we had the point I already graphed on my graph, that's your value that you're actually going to, it's called a turning point. So I'm just, for time-wise, I'm just going to plug these in. So first one, cubed root of 10 plus, negative 10, sorry, negative 10 plus 2. And then that plus 1's on the outside again. So when we get negative 10 plus 2, you get the cubed root of a negative 8. What number gets multiplied by itself 3 times and still gets us a negative 8? You're right, a negative 2. And then we're going to, so negative 2 is our one value, and then you're going to add 1, so our y value is now negative 1. Okay. For that, did I do that right? Oh, and then don't forget that negative in front of it. I'm sorry. There is a negative in front of this right here. That's why this little stinker right there, it's going to mess us up. Negatives. All right, so a negative times a negative is actually a positive. So this is a positive 2 plus 1, which is actually 3. Okay, so we want to change that. Make sure you have a 3 on there. Okay, and then now I'm going to do the same thing. This time, don't forget the negative. Sorry, I can't give you extra credit on these ones. Hopefully I catch my mistakes before you do. Negative 3 plus 2. And then negative 3 plus 2 is actually a negative 1. Negative times a negative is just going to be our positive 1. So we get 2. Okay. And then if I plug in negative 2 into here, negative 2 plus 2 is going to be the square root of 0. And negative 0 is just 0. So this is actually going to be 1. I'm going a little bit faster now. Negative 1 plus 2 is actually going to be a cubed root of 1, which is positive 1, but times that negative is going to be a negative 1. So this actually ends up being 0 because a negative 1 plus 1 is 0. And then plug in a 6. 6 plus 2 is 8. The cubed root of 8 is 2, but it's a negative, so negative 2 plus 1 is still a negative 1. Okay. So now we're going to graph all of these. We want to do this to see where x and y intercepts are, where it's decreasing, where it's negative, our domain and range. So for this one, we were right. So we did get our negative 2, 1 right here. See how it's right in the middle? This is actually our turning point, which is pretty cool. We got that from just our vertex form of our graph. So now let's go ahead and plot negative 10, 3. That's all the way off my graph. It's going to be somewhere all the way over here. And then we have a negative 3, positive 2. Then we have our negative 2, 1 that we already got. And then we have our negative 1, 0, which is also our x-intercept. And then 1, 2, 3, 4, 5, 6, negative 1. Okay, so this graph is pretty cool. It looks like this. It's a little hard to draw with this little crayon thing. That's my turning point, which means it's going to start turning off and going like this. Okay, so again, try to make your points a little bit more visible. And then we see that our domain and range now, domain and range actually get to be the same. I'm going to write domain first. So if I have domain, this is going to be my negative infinity. What's nice about these graphs is your domain and range are always, always, always going to be negative infinity to infinity. Okay, so then that means that the same thing for your range is just going to be the same thing. So let's write range below here. And we get to write negative infinity is less than x, which is less than infinity. Okay, that didn't work very well. There it goes. Okay, so then now our x-intercepts and our y-intercepts. So the one that's easy to tell right here was our x-intercept. So x-intercept, we get to say was a negative 1, 0. Remember, you can also look in your table for when that value was, for when our y equaled 0. Okay, for our y-intercept, that's when our x equals 0. It also looks like it's a decimal right here. So since we don't have the exact value, we're going to find it. So we have y, and then we're going to set our y value equal. Let me erase some of this. So our y value, we're going to go through, and you're going to set your g of x equation equal to 0. So when it's when x equals 0, so you're going to do 1 minus the cubed root of when x equals 0, so 0 plus 2 equals our y. Okay, so are we able to simplify that 2? Because 0 plus 2 is 2. Are we able to take the cubed root of 2? No, we are not. So we are just going to write this as a point, and our actual y-intercept, remember 0 is for x, and then you're going to write this as an actual point. So just write 1 minus the cubed root of 2. And that's it. That's all you're doing for the y-intercept. Our last part. So I have an x and y-intercept here. This is a decimal. If you guys got a decimal, I wouldn't mark you off. Our last part that I'm going to do for you guys, you're going to probably do number 8. I want you to try something on your own. So then we're deciding where our interval is actually decreasing. So where does it start decreasing? It's actually decreasing over our whole interval here. So we get to write negative infinity. It's going down the entire time. And then we always use x. Oh, no equal to though, because it's infinity. And then we have our off to infinity. So it actually is decreasing over our whole interval. The part where it's negative, I'm actually gonna have, I don't think I taught you guys negative yet, so I'm gonna show you guys. So negative is just when it's below the x-axis. So if you draw your little line across the x-axis, you see that the graph begins to go below right here. So the interval, it just is where it starts on your x-axis. So -1, which is less than or equal to, and your x, and then it's going off to infinity in the positive direction for your negative value, or sorry, your x values. It's going off in the positive direction. So anything negative is below the x-axis, anything positive is above the x-axis. Okay, so go ahead and try number 1 through 6, and then number 8 for your homework. Of course, if you guys have any questions, ask me through Google Classroom so everybody else can see your questions. Thanks again.